again for joining our webinar today. Today's webinar topic is the versatility and advantages of the Envision One for the dental market. Today's presenter is Miguel Gomez. Miguel is the 3SP Service and Applications Manager at EnvisionTEC. He is also the resident expert on the global 3D printing powerhouses cDLM technology, especially EnvisionTEC's newest best-selling 3D printer, the Envision One cDLM. Thank you so much, Miguel, for joining us, and now I'll hand it over to you.
Awesome. Thank you, Katie. All right, we'll get right into it. So welcome, everyone, to today's EnvisionTEC webinar. In this webinar, I will be presenting or giving a full introduction on EnvisionTEC's latest technology. Like Katie said, the Envision One cDLM. We'll begin with an overview of the DLP and the cDLM technologies. So in order to understand what makes the Envision One cDLM different, I will introduce the exciting new features with an overview of some of the external and internal hardware of the Envision One, and as also going over the Envision One RP software. So I'll also introduce some of the materials available for the Envision One and list off some of the applications. We'll take a closer look into one of those applications specifically, the 3D printed dentures. I'm going to give you guys an overview of the software with a demo. And then lastly, we're going to end it off with an exciting accuracy comparison between the Envision One cDLM and some of our competitors on the market. My name is Miguel Gomez. Like Katie said, I'm the 3SP Service and Applications Manager and the technical team lead for the Envision One cDLM printer. I've been with the company since 2014. So, to understand the Envision One cDLM and cDLM in general, it's best to know a little bit more about EnvisionTEC and the DLP technology. So EnvisionTEC was first founded in 2002 with the release of the first DLP 3D printer and the first printer capable of printing wax. EnvisionTEC has become a global provider of professional-grade 3D printing solutions with 6 process technology platforms and over 45 model configurations. EnvisionTEC's 3D printers are utilized in markets including dental, audiology, bioprinting, aerospace, automotive, jewelry, and entertainment. In 2014, EnvisionTEC received an FDA approval on 3D printed restorative crown material, and in 2016, EnvisionTEC was the first to receive FDA approval on split material for eGuard and denture material for the eDenture Plus. So what is DLP technology, and how does it work? So DLP uses a high-definition projection system to quickly stamp out a full image exposure one at a time, which makes it much faster than SLA technology. Pixels can be cured to a different depth, known as volumetric pixels, offering substantial edge finishes and overall improvements. So EnvisionTEC's patented contour grayscaling software controls the degree of white and gray in each pixel, allowing for a smoother surface finish and extreme accuracy. If we look at the diagram in the slide, we see a representation of the DLP process. So the light source, which is just out of frame down below, is located inside of the body of the printer. The light is projected and reflected off of a precision optic onto the DLP chip. And from there, the light is reflected up through the lens, where it is projected into the material tray. This entire process happens almost instantly. In this diagram, a 3D printed ring is adhered upside down onto the build platform, and the light is exposing the final layers of the ring's prongs. So let's take a brief overview of the range of printers that are currently offered by EnvisionTEC. On the left-hand side, we have the Vector 3SP. So the 3SP technology uses a laser to rapidly scan, spin, and selectively photo-cure resin in a unique approach that is proprietary to EnvisionTEC. Next to the Vector is the P4K, the newest released in the Factory series. The P4K utilizes a 4M pixel projector in artificial intelligence and pixel tuning to deliver extremely high-quality models. On the right side, we have our desktop family of printers. The center right is the Vita, which is historically one of EnvisionTEC's best-selling 3D printers for the dental industry, with a build envelope of 140 by 79 millimeters. the Micro Plus XL, to the right of the Vita, has a slightly smaller build envelope of 120 by 74 millimeters. Which brings us to one of our latest patented developments, the cDLM, or Continuous Digital Light Manufacturing. EnvisionTEC first filed a patent for continuous printing back in 2006, and this patent was granted in 2011. 5 years later, the Micro Plus cDLM was released, closely followed by the Vita cDLM, pictured to the left of the Vita. The Vita cDLM has a build envelope of 145 by 81.5 millimeters, making it slightly larger than the standard Vita. The cDLM technology, with its reduced separation forces, allows models to print faster and with less supports. This translates to faster production and less post-processing time for supported models. Finally, we have the Envision One cDLM, our latest in the cDLM family, with a massive build envelope of 180 by 101 millimeters. The Envision One cDLM is the largest, most advanced desktop 3D printer ever created. It is bigger, faster, and easier to use, more innovative than all the other 3D printers on the market. The Envision One cDLM is now CE certified, and Canadian certification is pending approval in 4 weeks. With a current lead time of 6 weeks on new printers, sales can begin today in Canada. So let's talk a little bit more about continuous digital light manufacturing. So cDLM technology speeds up the DLP process by adding a thin layer of oxygen between the layer being cured and the material tray. This layer of oxygen inhibits the resin from curing, which in turn adds many exciting properties. So the first advantage of cDLM is speed. The DLP process requires each layer to be exposed one at a time, with pauses between each exposure for separating and repositioning the platform. The oxygen utilized in the cDLM technology reduces the separation forces between the material tray and the build platform. Less separation forces results in a much faster print because we no longer need to pause and reposition the build platform between each layer. This in turn cuts several seconds off of the time needed to build each layer. The overall print time for orthodontic models on the Envision One cDLM is about 30% less than the Carbon M2. The second main advantage of cDLM printing is accuracy. Parts printed on the Envision One cDLM have isotropic properties, or consistent part properties in all directions. This is especially important in the Z direction because prior 3D printing methods, while not all of the same quality, have tended to have stronger X and Y strength, but less in the Z-axis. This has caused 3D printer users to strategically orient their objects on the build envelope for optimal strength in certain axes, or enhance final material properties with post-curing strategies. Parts printed continuously do not have clear weak points between layers and are consistent throughout with a smooth surface finish. Most importantly for dental, isotropic properties translates to incredible strength for long-term use in the mouth. So in common continuous 3D printing systems seen on the market today, oxygen is typically added below a thin rectangular piece of oxygen permeable film that covers the entire build area. That film allows just enough oxygen to penetrate to create an oxygen-rich liquid zone, shown in this diagram as a white halo just below the 3D printed model. This zone is the area where oxygen and photopolymer resin commingle. Because oxygen inhibits polymerization, nothing cures in this zone, which allows for 3D printing in free space directly above this area. Unfortunately, adding oxygen below a flexible film inevitably causes the film to tent or rise more in the center than in the outer edges. That means that the film has a dome shape during the printing process, and the oxygen-rich liquid zone is also domed. This in turn means the parts are no longer 3D printed on a flat surface, even in the free space above this zone. Referring back to the diagram on this slide, we see the dome causes a visible variation across the build area of 400 microns. This is almost half a millimeter, which results in inaccurate parts. Now if we look at the Domeless technology, So Envision took note of the accuracy issues created by this dome effect and released a patent-pending domeless material tray in order to remove the oxygen bubble and evenly control the pressure of oxygen across the entire surface of the material tray. One of the most important requirements for accurate 3D printing is a flat and parallel build surface across the entire build envelope. This is necessary because if there is any unevenness between the material tray and the build platform, the paper-thin layer of resin will not be cured in an even Z-slice, and accuracy will be compromised, as we saw in the previous slide with the dome effect of 400 microns. In this slide, we see a diagram of the domeless material tray in action. The dome effect has been removed, and in its place we have a flat, even material tray surface, a continuous line of oxygen-rich liquid zone, and even accuracy across the build envelope with a maximum deviation of plus or minus 50 microns. Let's take a closer look at the components that make up the domeless material tray. On the right side of the slide, we have an exploded view of the Envision One cDLM domeless material tray. Beginning at the top, we have an oxygen-permeable film, followed by the material chamber. Below the material chamber is the oxygen chamber. The vent holes allow oxygen to enter and exit the oxygen chamber in a regulated manner. The glass panel is the final part of this assembly, located on the bottom of the domeless material tray. The light is projected through this glass panel, through the oxygen chamber, through the film, past the oxygen-rich liquid zone, and onto the resin in the material chamber. The Envision One cDLM's domeless material tray is a consumable and should be replaced after 300 prints in order to maintain optimal printing conditions. The replacement domeless material tray is about $400 and shipping is included. The same type of product on the NextDent 5100 by 3D Systems is $1,000 for a replacement, and the Dentaform by Structo also has hidden costs that are even more detrimental. The Dentaform utilizes a LCD display that is not designed to interact with UV light. The UV light used during every print degrades this LCD display, and it needs to be replaced about every 2 weeks for $300, along with an extra $100 for the clear, nonstick film that is also a part of the process. So now we're going to talk about the projector. In continuous printing, the light intensity must be powerful enough to penetrate the oxygen-rich liquid zone and relay enough light or energy to the resin above that zone in order to build models accurately and quickly as the build platform advances at more rapid speeds. Which brings us to the next exciting feature of the Envision One, the 385 nanometer projector. Currently, most 3D printers on the market use a 405 nanometer wavelength light source, which was designed for standard film projection. The industrial 385 nanometer wavelength projector utilized by the Envision One was designed and optimized for 3D printing. This projector is an LED light source that does not require any warm-up time or any lamp replacement. The 385 nanometer wavelength is a shorter UV wavelength than the 405 nanometer. This results in more precise printed models and overall better accuracy. A shorter wavelength focuses the curing field. With a 385 nanometer wavelength, 96% of the part is cured during the print, whereas with 405 nanometers, that curing is only about 80%. This leads to light bleeding and curling issues. The 405 nanometer prints have a higher chance of curling during post-processing. This is due to the 80% cured green model that is produced by the printer. With 20% of the model left to cure, this allows for a higher chance of shrinkage and curl during post-processing. With 385 nanometer wavelength, the green model is cured to about 96%, which leaves only 4% to cure during post-processing. This reduces the chances for curling by about 5 times. Light bleeding is the effect of exposing light and curing material outside of the targeted areas, as seen in the slide. In the photograph, the top model was printed with a 385 nanometer projector, and the bottom model was printed on a 405 nanometer projector. The top model more accurately reflects the intended design with clean, sharp edges and smooth surfaces. With translucent materials like E1 Guide and E1 Guard, the 385 nanometer LED projector gives us a clear surface finish. EnvisionTEC's patented contour grayscaling technology takes this one step further, allowing for an XY resolution boost from the native XY resolution of 93 microns to only 60 microns. The Envision One cDLM also features dual linear slides in the Z-axis assembly. This gives the build platform superior stability and control throughout the print. This also eliminates shift lines inside the printed models. For data transfer, the Envision One has both wireless and wired network capabilities. An Ethernet port no longer needs to be within range of the printer, as the printer can easily connect to the network wirelessly. If both wired or wireless networks are unavailable in the printer's operating space, the Envision One cDLM has 3 USB ports for data transfer, 1 easy access port in the front, and 2 on the back of the printer. The Envision One cDLM shows off a brand new user interface called DLP CS. This is extremely user-friendly. The 7-inch touchscreen display works beautifully with this new simplified controller software with iPhone-like icons. The controller software also prompts the user whenever a new controller software is available. The operator can choose not to use the touchscreen and instead use a USB-connected mouse to navigate the software. Lastly, the Envision One cDLM has a massive build envelope of 180 by 101 millimeters, or roughly 7 inches by 4 inches. This is the largest EnvisionTEC desktop 3D printer to date, and provides plenty of platform space for dental models during their print. This is only 10 millimeters shorter in the X direction than the Carbon M2. Now, as for the software, the Envision One RP software has an all-new and highly intuitive layout. All necessary tools are readily available with no subfolders or tabs needed for 3D printing workflow. You can easily import a part, rotate, add supports, nest, and export as a job file directly into the printer in a matter of minutes. It's easy to use for beginners and advanced users alike. So let's take a closer look at the Envision One RP software with a demo. So on our display here, you can see this grid outline is what shows the build area of our printer. So I'm going to give a quick overview of the buttons that you see on the screen here, and then we're going to just pull in some models and show some of the other features. So just here at the top, we have undo, redo, and we have save if you're working on a project and you want to save the project, and also a zoom button to zoom in and out of the platform space. This is our menu bar that has many of the common options shown in many software: new, open, open last, save, save as, export. We also have some preferences here. So we can change our projection type so that this has more of a perspective view instead of orthogonal. We can change our measurement units if people are more comfortable with inches. We can change our scroll direction if your CAD software you're using already has reversed scroll direction. And we can enable our automatic placement when we're loading in our models. Also, we have some shortcuts here that can make your workflow even quicker, and they're all here instead of the shortcut tab instead of preferences. Now we're going to jump in and pull in a model here. So basically, I hit the plus button. That opens up a folder and pulls in my model. As you can see, my model is currently outside of the build area. As soon as I click the translate crossbar on the top left of the model, and I start to drag, it will pull it in immediately into the build area. This basically creates a safety net so that if I accidentally translate my model outside of the build area, it prevents it from going that far. So we're going to talk about what these icons are around the model. So this first icon on the top left is the translate tool. So basically I can translate or slide my model around the build area. Another safety feature that has been enabled is I can't pull my model away from the platform, accidentally causing an issue where the part wasn't flat to the plate. So the model is always going to remain on the plate at all times. this top right icon is a slicing, or we can select a different plane. So for example, if I don't want to print flat on this bottom piece, I can choose to print flat on this plane here. And just as easily, I can bring it right back to this bottom plane here. This tool down here on the bottom right, let me just bring this model over so I can make some space, is a duplicating option. So if I click and drag, I can create duplicates of the models that I'm working with. As for this bottom left tool, this is a cutting tool. So basically, if I wanted to shorten my print, so right now, as you can see, these two models at the height that they're at would take about 18 minutes to print at 100 microns. So if I come in here and I don't need this excess, let's say this gum line, I can cut away. Sorry. And cut this one away. So as I cut away the model, I can shorten my print down to about 12 minutes. I can also use common shortcuts like Control-Z and revert any changes that I might have made. And that's about it for our icon here. Now also, if you see this rotating tool here, I can also rotate my models in any direction. And like I said before, depending on whichever direction you rotate in, it will always stick to the plate. It will always make it flat to the plate, just in case. Now, if I wanted to bring it back to this flat plane, basically I select my plane selection tool and release. On this left-hand side, we have a couple options that we're going to go over. So with the model selected that I want to modify, if I click this first option, this brings up my scaling tool. Typically in dental, scaling isn't really used. You want to make sure your model stays true to whatever the design was. So this isn't a tool that's going to be necessary inside of dental, but I'll still show you guys how it works. So I can scale up in increments here, or I can set the actual size that I want any axis to be, and it'll automatically make a uniform scale all the way up to whatever that number is. This next option, the orientation tool, allows me to rotate in kind of like in snaps of 90 degrees, or I can manually add certain degrees or make a custom orientation here. This also has the Enable Select Base tool. So if I enable this, any base that I touch will flatten down to the plate, which is honestly in the dental space, I think it's one of the best tools to have. I know many people that use CAD software, any sort of generating software, and when it comes to making a model flat to the plate, it's super useful to have something as easy to use as this, where I can just click any flat plane and it makes it stick to the base. And as you can see, this orange that's on the bottom represents what's touching the plate. So if at any point in time, let's say I set this up and I see that this is an orange, that means that that orange isn't touching the base or the plate. So anything that's orange is touching the plate. The next tool we have is the positioning tool. So if I hit center and platform, it'll center the model on the platform. So if I wanted to make an extra copy of this, I can also do that in here. And since I have them both selected, I can hit auto place all. It'll automatically center and place the models in the middle of the platform for me. The last tool I have is the support generation tool. Now, with orthodontic aligners like the ones we see on the display here, they're not really meant to have any supports. We can print these flat to the plate and should be no issue. So for this demonstration, I'm going to pull in a Cunning bridge model that's hollow and would need a couple supports. I'm going to delete the selected models here, and I'm going to import a generic Cunning bridge model. Again, my model was imported outside of the build area. As soon as I hit this crosshair and start moving, it'll jump right into the plate. So if I scroll down to the bottom or rotate this, I can see that this model is hollow. So with certain hollow models, you can get away with not supporting, but it's always best, especially with down-facing flat surfaces like this one here, it's always good to have some supports there just to be safe. You want to make sure that your models keep their design intent so that there isn't too much deviation. So adding a couple supports are just going to help. Now, if you look at these supports we're about to add, if I come over here to the support tool, I can choose to add a height. So you know how I was saying that the model is going to be flat to the plate no matter what? If we add supports and we make this option here, let's say 4 millimeters, right? And I hit generate selected, it's going to bring the model 4 millimeters off of the plate and add supports to the bottom. Now, because of the model being channeled and leaving room for material flow, it's really not necessary to put this model up on supports. The only place we need supports are right here on the inside of the model. So what I'm going to do is I'm going to make this minimum support height 0 and then generate selected. As you can see, if I look at this from the side, there's no support. It's not lifted off of the plate, so we're keeping our print times pretty, as quick as possible. And then we look over down in the bottom, we can see that those down-facing flat surfaces are being supported to make sure that everything is safe. The last option I'm going to discuss here is this quick print button. So what we're going to do is we're going to remove the selected supports. And what this button does is basically allows us to prepare the print or prepare the scene for a print as quickly as possible. So what I'm going to do is I'm going to select this model and hit this quick print button. And it says preparing scene to print, so it's going to automatically add supports. And then once it's done adding supports, it's going to jump me right into the print window. So all I have to do is pull the model in. I don't even have to translate it. All I have to do is pull the models in that I want to print, hit the quick print button. It'll automatically orient, place, support, and then jump you to this generation window. So I can literally prepare my models in minutes. So basically here, all I would have to do is hit Save Job. I'll just select this folder to show you guys what would happen. So it's going to give you a preview of what each layer will look like, or the printing process would look like. And then at the end, it's going to tell us the job was done generating, and we can open the folder directly from this window. So here's the build job we just generated. As you can see, all of our build layers are there. If we open up this preview, it shows us the preview that's going to be shown on the printer. And again, the generation took less than a minute. The last feature I'd want to show you guys is the layers option. So if I select this model, and I come over to this eyeball here, it enables the layers tool. So this allows me to see from the first layer to the very last layer how each layer is going to print inside of this build job. This is good for when, if let's say you didn't want to add support to this model and you wanted to see if there are any overhangs or any floating islands. And we can also see how well our support generation did in taking care of those areas. So as I'm going through here, we can see a couple areas where we see some islands. So the first one here is right in this area, and we can see that our tool here did a very good job at supporting. The next area is right up here in our support generation software. Again, all we did was hit generate. We didn't have to do any specific points or set them anywhere. As you can see, our support generation tool did a good job of recognizing this area as an area that needed support and support automatically. And then lastly, if we keep going, we can see that it covers this area here. This area doesn't necessarily need support, but again, it's always better to have just a few supports to make sure everything stays intact. This print would take roughly about 25 minutes, and this model is about 24, 25 millimeters tall. So this is about an inch tall model, printed in about 25 minutes. All right. So now that we've gone over the software, we're going to jump right back into this presentation. So now that we understand the new Envision One RP software, and how to translate a model into a build job for the printer, let's take a closer look at the materials available for those models and the applications. The Envision One cDLM currently has 7 dental materials available, with more to come. There is a wide variety of materials to meet your specific needs. Pictured on this slide is a full platform of denture bases printed in E1 Denture Plus, orthodontic appliance models printed in E1 Monolithic DLP, and partials printed in the castable Press E1 Cast. To go more into the materials available, the E1 Model Beige is a low-cost orthodontic material for generic suck-down models. The E1 Model Light is a more advanced version of the beige material and ideal for crown and bridge models and orthodontic appliance models as well. The E1 Denture 3D Plus, pictured to the right, was developed for making denture bases. Also pictured with this material is the E1 Dent 400 CNB MFH and comes in several shades. This is a biocompatible Class 2A FDA-approved solution for the accurate 3D printing of crowns and bridges. E1 Dent 400 MFH can also be used for the 3D printing of very tough veneers that are extremely accurate and have very fine surface finish, as well as denture try-ins. E1 Guide Tint is a strong translucent orange material used for high-precision surgical drill guides for use in implant surgery. The material is resistant to disinfectants and can be sterilized using gamma rays in autoclave without affecting dimensional stability. E1 Guard is pictured towards the center and is used for the production of accurate splints and retainers. Press E1 Cast is a wax-filled photopolymer material for the production of full anatomical crowns and bridges. You can also print partials, as shown in the previous slide. This material has a moderate amount of wax, which allows for a quick and easy burnout. Now, we'll take a more in-depth look at a specific and exciting application for the Envision One cDLM. This is 3D printed dentures. Dentures have always been a difficult and time-consuming product, especially when made with traditional processes. 3D printing expedites this process. A full 3D printed denture workflow would look something like this. So we take a conventional alginate impression, create bite rims, wax rims, and a bite registration. The dentist would then need to provide tool, mold, and position, centric relation, vertical dimensions, occlusal planes, etc. We would then scan the impression and bite rims using a lab or a tabletop scanner. Design the denture or try-in using ExoCAD or 3Shape design software, or upload the data and records to an outsourcing center such as Avident, Full Contour, or Blue Sky Bio. Once the information is translated to an STL file, you can then 3D print the try-in. Rescan any adjustments needed and upload the file or import into your CAD software. Design adjustments, save the STL file. Use this new STL file to print the final denture. So there are 2 types of 3D printed dentures. There's monolithic dentures and 2-part dentures. The monolithic denture is a single model comprised of denture base and teeth with no assembly required. Monolithic dentures are printed in one material, so more time must be spent with stain and glaze to transform the denture base into a tissue color. The 2-part denture base, or the 2-part denture, is an assembly of 2 separate prints, the denture base in the E1 denture and the denture teeth in the E1 Dent 400 MFH. The 2-part denture requires more time for assembly, but less characterization is needed. Here we see a fantastic example of a fully characterized monolithic denture. This was printed on the EnvisionTEC Vita and characterized by Valerie Cooper McMillan and John McMillan. The material cost of this monolithic denture was only $7.50. The monolithic denture was printed. All uncured material was removed using 99% isopropyl alcohol. The model was then post-cured, then characterized using stains and glazes. For the 2-part denture, there are post-processing steps that need to take place once the denture base print in the E1 denture material is complete. First, we remove the parts from the platform and clean in 99% isopropyl alcohol to remove any uncured material. Place the parts in a cup of 99% IPA and place the cup in an ultrasonic cleaner for 3 minutes. We then dry the parts with compressed air. We remove the supports from the denture base with snips. We then post-cure inside of an EnvisionTEC curing unit, and we follow the instructions depending on the specific unit. We then apply the E1 denture resin into each denture tooth socket using a disposable pipette. We press fit the denture teeth printed in the E1 Dent MFH and clean up any residual uncured resin with a dry paper towel. We post-cure the assembly in an EnvisionTEC curing unit to bond the teeth to the denture base. We then remove the supports from the denture teeth with snips, lightly sand the supported area. As an option, we can stain and glaze for characterization. And lastly, we pumice and polish to a desired finish. So that was it for our 3D printed denture segment. Now we're going to jump over to understanding the dimensional accuracies of our Envision One. So for all dental applications listed so far, surface quality as provided by EnvisionTEC's patented grayscaling technique and the Envision One cDLM's native pixel resolution is important. But in order for the model to function as intended, accuracy is paramount. So what is accuracy and what is resolution? Accuracy is how closely a final 3D printed model measures up to its digital model. Usually, dimensional accuracy is measured within a certain XY tolerance, or it's reported as a total percentage of a scan accuracy against the model. The only way to determine accuracy is to print the model, scan this model, and then compare it to the original digital model. On the other hand, resolution for DLP and cDLM technology is the fixed number of pixels displayed by a projector. The American Board of Orthodontics was the first dental organization to publish standards for accuracy requirements for digital models in 3D printing in 2016. EnvisionTEC's internal accuracy standard is actually higher than the ABO's requirement of 99.9% accurate within 200 microns. We performed a test to see how EnvisionTEC's printers compared to some of our competitors in terms of accuracy. The exact same STL file was printed on a variety of different printers, and the accuracy was tested on the exact same 3D scanner. So first, we're going to take a look at a aligner model printed on the Envision One cDLM. So we printed this flat to the plate. Now, according to the ABO standard of 200 micron accuracy, we were able to hit that 99.9% target. Now, as for EnvisionTEC standard, we like to keep a standard of 100 microns. So horizontally, at 100 microns, we were at 97% accurate, which is extremely close to that 99% target, even at 100 microns. Next, we're going to take a look at the Form 2 versus the Envision One cDLM. So the Form 2 model at 100 microns, which again, this is EnvisionTEC standard, is at 70% accuracy. And just to repeat, the Envision One was at 97%. Now, if we look at the ABO standard, which was 200 microns, the Form 2 came close at 95%, but did not hit that target of 99.9% accuracy, whereas the Envision One was able to do that. So that's for orthodontics. The next thing we're going to do is we're going to take a look at this accuracy scan that was created by Dr. Auguste de Oliveira, DDS, and this is to test accuracy for Credit Bridge models. So we're going to first take a look at our Vita, which is one of our most famous dental printers on the market. The Vita, as you can see here, and all of these, the next few scans that I'm going to show are basically centered on the plate. So the Vita was able to hit 72% accuracy at 50 microns with this very tough test. And at 100 microns, we're able to hit 94%. Now, when looking at the Envision One, the same model scanned in at 50 microns at 65% accuracy. This is only 7% less than the Vita. Now, mind you, the Vita does have a smaller build envelope due to the projector location. This gives us the Vita a smaller native pixel size of 73 microns versus the 92 microns on the Envision One. This is a 26% difference in native pixel size. But due to the 385 nanometer wavelength and the active contour grayscaling, the Envision One is only 7% shy of hitting the exact same target as the Vita. And at 100 microns, it's only 2% different. Now, as for the Micro XL, we're able to get 68% of the triangles accurate at 50 microns. And at 100, we're able to hit 92%. Now let's look at one of our competitors, the Carbon M2. So the Carbon M2 centered on the platform, again, all of these are centered on the platform, we're at 65% accuracy at 50 microns. And at 100 microns, we're at 91% accuracy. Now, looking at this specific slide, there's something that I'd like to point out. So in a slide that was discussed here earlier in this presentation, we were talking about the domeless versus the domed printers. So dome printers are the more common printers on the market. The Carbon M2 is one of those printers. Now, one thing we can look at, I think is the most interesting. So the Envision One and the Carbon M2 are pretty close to each other when it comes to accuracy. As you can see, we're at 65% accuracy at 50 microns on the Carbon M2, whereas on the Envision One, we were also at 65% accuracy. The Carbon M2 at 100 is at 91, which is only honestly 1% less. But I want you guys to take a look at, I hope you guys can see my mouse here, but if you look at this area here, this is the most interesting part that I'd like to show you. This part here. So if we look at this flat plane that is supposed to be, 100% flat here in this model, we can see a deviation here. It looks like it's a little too skinny or a little too thin. It's a little bit in the blue. If I come back to the Envision One cDLM, I want you guys to look at this 100 micron scan. This is off of the Envision One. We have no deviation there on that flat plane. This is basically proof of that domeless basement. This is the domeless material tray in action. We're able to get excellent accuracy on a flat surface at 100 microns versus something that's more traditional on the market, like the Carbon M2. Now, if we look at the 50 micron scan, we can see that it's just shy. You can see the baby blue here. Now, we do expect a 50 micron, at least a 50 micron deviation in some areas. But if we look at this 100 micron scan, we can see that at 100 microns, we are well within the target. And here on the Carbon M2 at 50 microns, we can definitely see that there's some more deviation with that dome effect. Now we're going to jump into, like I said, we'd already spoke about the Formlabs in the orthodontic space. Now we're going to show some scans off of the dental space. So the Form 2 is centered on the platform. 38% accuracy at 50 microns with this very, very tough test. I mean, it is a tough test that Dr. Augusto de Oliveira put together. And you can see that we're at 38% at 50 and 64% at 100. And if we look at the Moon Ray, another competitor on the market, we can see that it's even worse. We're at 26% accuracy at 50 microns versus, and then also 50% at 100. So all in all, if we look at this list here, we know that the Vita is going to come out on top. I mean, it has, a smaller build envelope, which does limit the amount of models you can print, but you do get a little bit better accuracy. It also doesn't have the cDLM, so the speed is it's not going to be as quick as the Envision One, but you are going to get just a little bit more accuracy because your build envelope is smaller. But if we look at the Envision One, not only do we have the speed, we're very close to hitting that accuracy that the Vita is able to give us with a larger build envelope. So we're able to fit more models on the plate. We have the accuracy and we have the speed. And with the dome versus domeless, if we look at the Carbon M2, again, that domeless material tray does give us the upper hand when it comes to that accuracy in the Z direction. All right, so the floor is now open for questions. Please type any questions that you may have in the questions section, and I'll do my best to answer them. Just as a reminder, I am the technical support lead for the technology, so I can answer any technical related questions you may have. So let's go ahead and we're going to open the questions now. All right. So it looks like we don't have any questions here. Katie, are you there? Oh, here we go. So,
Yes.
can you print the models in glossy or matte finish, or only one type of print finish is available? So, with the Envision One, because of the cDLM and that oxygen-rich liquid zone, we're actually able to print a much smoother surface finish because we're not tearing away from a film. So, with some of our materials like the eGuard and the E1 Guide, and I believe the E1 Denture 3D Plus, we're actually able to get a little bit more of a smoother glossy finish. Now with some materials like the E-Model Light and the E-Model Beige, that surface finish is still like a matte finish. And then also just to add to that, there are post-processing methods. So we can, if you do have a matte finish model, like for example, if you print a matte finish model on the E-Model Light and you do a polish with pumice, you're actually able to get a really nice glossy surface finish. Now we also have a question that says, is build plate size directly related to speed and accuracy? So this is something that's been a question on the market for quite some time. Is if you print larger pieces, you have to, with traditional continuous printing, you would have to slow down to allow for material displacement. With the Envision One cDLM, because we do not have the dome, because we have a domeless material tray that more evenly distributes the oxygen through the oxygen permeable membrane, we're able to provide a much quicker print, and also we don't have to lose out on the accuracy. So we're able to get a nice accurate finish because we're honestly still printing just like traditional DLP printing methods. The only thing we're doing is we're adding that oxygen layer, increasing the accuracy by using a 385 nanometer projector, and we're still keeping that nice flat surface. So yes, the build envelope size is directly related to accuracy. So the larger you go, the larger your pixel size is. But with the consort grayscaling and with a 385 nanometer wavelength, even though we have a larger build plate, with the Envision One, we're still able to get that accuracy that we have with previous EnvisionTEC technology. So I have another question here. Is anyone on the market able to print ortho aligners? Yes. So we're talking about the ortho aligner, like the suck-down models. Everyone on our, in our ortho space is able to print the ortho aligner models very, very easily. So we have another one here. Which one is more accurate, 50 microns or 100 microns, and why? So this is another thing this is an excellent question. So when it comes to resolution and accuracy, they also go hand in hand. So the resolution of a print determines how smooth or how nice the surface finish or how well the details are going to be in the print. The accuracy is determined by your pixel size, but also by the resolution. So the more smooth surface you have, the more of a fine finish, the more it's going to replicate the intended digital design. So if we print at 50 microns, that means that our layers are half the thickness than at 100, giving us a little bit more accuracy because that resolution, that surface finish is going to reflect more of what was intended with the digital file. So I have another question here. So are EnvisionTEC printers require proprietary resins, or is it open? This is a closed system. So the only resins that currently that we recommend or that are sold with our printers are EnvisionTEC materials. I have another one here. So why models with pinned articulators have a higher chance of falling in the basement? So I know that there is one thing that we need to keep in mind. So as I was showing you guys in my software demo, and this is a great question. For example, like the Vertex cups. When people use Vertex cups with their Crown Bridge models, sometimes that vertex cup sits a little too low than the model does. So when we go to set up the build, as you know, like we said earlier, that model is going to sit flat on the plate. Sometimes the thing that actually makes contact with the plate is that vertex cup because it sits a little bit lower. So it might not be that pin models are giving you the issue. It might be that your vertex cup is sitting just a little too low. The best thing I would recommend to see if that's actually the issue is, for one, pull in your models into the Envision One RP software, look at the bottom side, and you're going to see orange. Whatever is orange is actually making contact with the plate. If it's your vertex cup, I would suggest putting your parts on supports so that it's not just your vertex cup printing and then all of a sudden your model starts to print. This should alleviate some of those issues. So another question here, why are some models shorter than others? So this is all dependent on the lab, honestly, and the way that the lab works. I know that some dental labs have fine-tuned their cut and bridge models to be just like they've basically cut the fat, made it as lean as possible so that you're only printing what's absolutely necessary. And these labs have also made their models hollow, so they're basically printing only the necessary, plus they're cutting away models from or material used from that solid model and printing only the hollow models. So again, the reason why some models are shorter or why some models are hollow is because of material costs. Most labs want to save on material costs, which is perfectly fine with the Envision One. Again, with the support generation software, with all the safety nets that have been placed, it's very, very easy to push the boundaries of your models, you know, go as lean as possible and get a successful print. The software used with the EnvisionTEC or from an external scanner. So it depends on what software you're referring to. So if it's the software that you were watching me use to basically nest and set up my models, that's proprietary software that comes with the purchase of your Envision One. This comes with any purchase. No extra purchase is necessary. It comes with the purchase of the printer. And if anyone would like a demo, please let us know. Just looking at the questions here. So I have a question here. How long, time-wise, is the post-processing exactly for a full tray, 6 full arch models, after the printing is complete? This is a great question, but there are also many variables that come with this question. So it all depends on the post-process that you're doing. Some methods that I've seen are like using a ultrasonic cleaner so that it's the least amount of labor possible, the least amount of human labor possible. So basically you take your models off the plate, you know, you dunk them into some alcohol, kind of like we explained in the presentation. We put them into a cup, into the ultrasonic cleaner. We turn on the ultrasonic cleaner. We walk away from it. You know, we let it do its thing for 3 to 5 minutes. We come back. The models have been fully cleaned. At this point, there's also another method that I've seen labs use where they can either lay them out on a paper towel with a desk fan, and that basically you walk away from it again. It completely dries off the alcohol. You come back. You put it into your post-tune unit. If you have an auto flash, 250 flashes for E-model light, a couple of times. Literally takes, I think it's less than a couple of minutes, really, with the auto flash. Now, depending on the curing unit you have, some units are, again, a little bit more hands-off, like the UBCA 1000. If you're using that one, basically you lay your models out, you close the drawer, there's lights on both bottom and top, you run it for 5 to 10 minutes, and it's very hands-off. It takes a little bit longer, but it is meant to be hands-off versus the auto flash where, if we run a cycle of 250, we have to flip them halfway and do another 250. So it adds maybe a couple of minutes of just human labor, but it is a quicker process. Are there any annual fees for the software? So currently there are no annual fees for the software. Like I said, it comes with the printer and it comes with the license. So as of right now, the software is not subscription-based. So I have another question here. When does the basement need to be replaced? We know that after 300 prints, however, can we visibly see when the plate needs to be replaced? This is a great question. So we say 300 prints, and basically that's our recommendation. That's the recommended amount of prints. After about 300 prints, as with any material tray in any continuous market or in any continuous printer, after so many prints, the film starts to become a little bit more hazy. It starts to lose permeability. So it still works fine. You could probably go 350. You could probably go 400 prints with the material tray. We say 300 prints because we want to maintain that high level of accuracy and quality from your models. If you choose to go beyond the 300, you can probably do so, and you might have excellent results for 50, 100 prints after. But we like to have that safety net of 300 because we want to make sure you are providing to your end users or to your dentists the highest quality of models. And after 300, it could possibly start to waver. So. And there was I think that's it. That's pretty much it for our questions here. Let's see. Hi, thanks for this great presentation. Are you going to comment on the cost of the system, printer, accessories, post-grading? So I will not be discussing any of the pricing here, but I'm sure that you will be reached out to discuss the pricing.
And everyone have a great day. Thank you so much for joining.